Hello, this is our presentation on applications of biomimetic ligament regeneration for prevention and treatment of post-hysterectomy pelvic organ prolapse. So the clinical significance is that over 50% of women over 50 experience POP or pelvic organ prolapse, which causes a number of issues. First of all, the prolapsed tissue took up space in the body, and it not being there anymore causes the bladder and large intestine to sag down, which causes both urinary and bowel incontinence. Secondly, it causes sexual dysfunction and also, of course, psychological trauma because it's part of your body turning inside out. The market is $1 billion USD strong, so there's a lot of profits to be made here as well as good to be made. And in America alone, up to 200,000 women are treated annually for this condition. As you can see on the right side of the slide, there is a diagram, and at the very top, you can see the cervix. So in hysterectomies, frequently the cervix is removed as part of it, and there's lots of connecting tissue which acts as support for the vaginal walls. So this being gone causes a number of complications, including pelvic organ prolapse. Since it just simply can't hold it up anymore because the surrounding tissue is weakened from the extra strain or just not there anymore because it's taken out. So up to 23% of women experience pelvic organ prolapse because of this. Now, another big issue is that for the type of mesh implants that we've been looking at, they use polypropylene, which is a rigid plastic that basically causes scarring on the walls because the vaginal walls and surrounding area move a lot. There's lots of moving organs there, and having a rigid mesh basically scrapes against it, since it doesn't. Since you need basically something that is compliant, that moves with the vaginal wall, and so this causes organ welding because the scar tissue starts to build up, but the scar tissue is indiscriminate with where it connects to. So it can connect two organs together with the scar tissue, which causes issues. Of course, you don't want organs that aren't connected to be connected.
Our approach would be to make an implant that would be an electrospun collagen fibril mesh. The actual physical design of this mesh would be similar to those made from polypropylene, but this one would be made out of collagen fibrils and would be seeded with autologous cells, most likely ligament fibroblasts. This implant would be it would attach the vaginal cuff and the sacral bone either during a hysterectomy for a preventative procedure or when the pelvic organ prolapse symptoms start to exhibit. This would be performed during an abdominal or laparoscopic sacrocolpopexy. For this approach, by encapsulating the mesh in autologous cells, this could reduce the mesh exposure, thereby reducing the organ welding. And by using autologous cells, you can reduce the risk of rejection as well. By performing this during a hysterectomy, you could also reduce the number of procedures that the patients would have to go through in their life, rather than having a second one when the actual symptoms start to exhibit. This approach is not without its drawbacks, though, because in order to have those autologous cells, you would need to make incisions to get a source or something like that. It would also not be as cost effective as polymer meshes.
The gold standard treatment for post-operative prolapse is an implantation of polypropylene mesh. These devices are produced by Johnson & Johnson and Boston Scientific. There is some variability in these products, including pore size, molecular weight, and mesh geometry. These differences in the device makeup can lead to varied outcomes. However, current solutions on the market for post-operative prolapse are being reviewed by the FDA for causing undue harm to patients. Current devices have also been banned in the UK, Canada, Australia, New Zealand, and France. The FDA ban was on 2 companies who used rigid materials such as polypropylene and polyvinylidene fluoride in their implants. Our approach uses a soft electrospun collagen fibril mesh, which would not cause the problems of the current devices. The audience for our device would include women undergoing a hysterectomy, women experiencing post-operative prolapse, and OB/GYN physicians. In order to design a device that effectively serves these clients, we need to conduct further research of the mechanical properties of pelvic functional anatomy.